Hi guys, it's your science teacher here with another video. This time I'm going to do another required practical with you, and it is halogen displacement. We're going to look at the reactivity of the different halogens, and we are going to see which halogen displaces another halogen. So what I actually have here is I have a 3x3 grid of different spotting tiles, and I've written on the different chemicals that I'm going to add on to the different spotting tiles. So this top row here is going to be filled up with chlorine water. This second row is going to have bromine water along these three, and this bottom row is going to have iodine along the bottom. This column is going to have potassium chloride going down. This column is going to have potassium bromide going down, and this is going to have potassium iodide going down. Okay, so what I'm going to do is I'm going to put all the different halogens and the different halogen salts onto my spotting tiles, and what we should see is the most reactive halogen will always displace a less reactive halogen from its salt. The way I like to think about this is like Love Island. In Love Island, they like to be coupled up, and halogens are the same. They like to be in a couple. Now, they can't always be in a couple because the most reactive will try and steal the salt. Just like in Love Island, they're going to try and steal. So what we should see is the most reactive halogen will always steal the salt, which in this case is potassium. So the most reactive halogen is going to try and come in and always steal that potassium. Okay, so I've added all the different chemicals onto the spotting tiles now, and I want you to see what has actually happened. For comparison, I've also included the halogen waters by themselves, so you can see the colours of them originally. So let's look at the first reaction and work our way over. So chlorine plus potassium chloride. Has the chlorine displaced itself? Well, that's not going to happen, is it really? Because chlorine is the same reactivity as chlorine, so it's not going to have a displacement reaction. However, let's look at the next one, chlorine plus potassium bromide. You can see there's definitely been a colour change here occurring. Look at this colour here of the chlorine water on its own. It's changed here because the chlorine is more reactive. It stole that potassium, hasn't it? It's taken it away, just like in Love Island. Then let's go over here. You've got chlorine and potassium iodide. Chlorine is more reactive than the iodine, so it stole the potassium away from it. Let's go on to the second row. Bromine water is actually colourless as well. It doesn't really have any colour to it. Bromine plus potassium chloride, well, it stayed colourless. Nothing's going on really there. Bromine and potassium bromide, well, same reactivity, just like with the chlorine example. Let's have a look at the last one though, bromine and potassium iodide. We can clearly see that it's changed colour. There's been a colour change occurring here. That means bromine is more reactive than iodine and has displaced it. It stole the potassium away. And then look at the bottom row. There has been no clear colour change there, no displacement taking place, and that should be seen really because iodine is the least reactive halogen, so no displacement has occurred.